Section 6.4 is about completing the square. We're going to begin by looking at the square root property. This is another property we can use to solve quadratic equations. And it works when you have a perfect square on one side. You can then find the solution by taking the square root. Here's an example. X squared plus 10x plus 25, that's a perfect square trinomial, which means it comes from an x plus 5 squared equals 49. Now the reason this is helpful is because we have a binomial squared, we can take the square root of both sides. We don't have to worry about setting it equal to 0. We can cancel the square and the square root, leaving x plus 5 equals plus or minus 7. Because remember, when you introduce a square root, you've got to introduce a plus or minus in front of the square root. And because the square root of 49 is 7, it's positive or negative 7. Then we can finish this by subtracting 5. And when I write my answer, I usually write it negative 5 plus or minus 7. So now what are the two solutions? Negative 5 plus 7 and negative 5 minus 7. So that would be negative 12 and 2. Here I'm told to solve by using the square root property, so I'm not going to worry about getting it equal to 0. I am going to notice that this is a perfect square trinomial again, and it's created with an x minus 3 squared. Now we'll use the square root property. We'll take the square root of both sides. Don't forget when you do that, include the plus and minus. So we'll cancel x minus 3 equals plus and minus the square root of 32. Now 32 is not a perfect square, so this square root is a decimal number. So I'm going to leave it as a square root for right now while I continue to solve this. I'm going to add 3 to both sides and get a solution of 3 plus or minus the square root of 32. Now to write my two solutions, I need to take this and plug it into a calculator. When I do that, I get a negative 2.7 and a positive 8.7. And we'll round those to the nearest tenth. Even though this is an exact answer, this answer is a little bit more meaningful for us. So these are my two solutions. Now sometimes you don't always have a trinomial that's a perfect square trinomial. When you don't, you can do something called completing the square. That's a method of creating a perfect square trinomial so that you can use the square root property. And these are the steps for completing the square. You find half of what b is, you square that, and you add it on to the end of the trinomial, and then solve the equation accordingly. So here's an example of that. We have an x squared plus 12x. I'd like to know what the c needs to be to make this a perfect square. So I would take half of b. In this case, my b is a 12. So multiply 12 by a half, and you'll get a 6. So half of b is 6. Then I'm going to square that, and I get a 36. So 36 would be the perfect c that I would want to make this a perfect square trinomial. Here we're asked to solve by completing the square. Currently this trinomial is not a perfect square trinomial. So I'm going to move the 20 to the other side to make room for the perfect c value that I'm looking for. So I'm going to leave a space here, make it equal to 20. So now how do we complete the square? We take half of b, so here's 8 times a half, which is 4, and then we square that, 16. So now we're going to add the 16 onto the end, but because this is an equation, I have to keep the scales balanced. So when I add the left side, I also have to add 16 to the right side to keep it balanced. Now we have a perfect square trinomial that's created from an x plus 4 squared, and on the right side we have 36. Now we can solve this using the square root property. Square root of both sides, so x plus 4 equals plus or minus the square root of 36 is just 6. Finishing up by subtracting 4 from both sides. So two solutions, negative 4 plus 6 and negative 4 minus 6. So it looks like negative 10 and 2. Here's another completing the square problem, but one thing we haven't talked about yet is that completing the square can only take place if the leading coefficient, or the a, is 1. In this case it's not. So if that number is not a 1, you're going to have to divide everything by that number to make it a 1. So we'll rewrite my trinomial as x squared minus 5 halves x plus 3 halves equals 0. Now this is not a perfect square trinomial, so I'm going to subtract the 3 halves from both sides. I'm doing it the same way I did the last one. It's just now we're going to have to deal with some more complicated fractions. So now to complete the square, I take b, 5 halves, half of that, because that's the steps for completing the square, take half of that is 5/4, and then square that. So 25/16. So I'm going to take 25/16 and add it to both sides, because I have to keep the scales balanced. Now the left side is fairly easy. We know it's a perfect square trinomial because we've set it up that way. We've completed the square. So we know it's an x, we know it's a minus, and we know that 25/16 comes from 5/4. But now we've got to put these two fractions together by getting common denominators. I'm going to multiply -3/2 by 8/8. So then I get a -24/16 plus 25/16. And when you add those together, you get 1/16. So that's what the right side will end up becoming. Now we will use the square root property. So x minus 5/4. This is actually not too bad, because the square root of 1 is 1 and the square root of 16 is 4. Don't forget the plus and minus. We'll then add 5/4 to both sides to finish. So we end up with 5/4 plus or minus 1/4. So putting those together, 5 minus 1 is 4, and 4/4 is a 1, and then 5 plus 1 is 6, and 6/4 is 3 halves. Here's our last example for completing the square. This is not a perfect square trinomial again, so I'll move the 11 over. Leave room for my c. I'm going to take half of b and square that. So that's a 2 squared, which is a 4. And then I'm going to add 4 to both sides. So now we have a perfect square trinomial that comes from an x plus 2 squared, and over here, -7. Using the square root property now, taking the square root of both sides, I get x plus 2 equals plus or minus the square root of -7. It's at this point where we run into a problem. You can't take the square root of a negative, but if you remember, we've already learned about something called complex numbers. So we should know how to deal with this now. Instead of plus or minus the square root of 7, we're going to take the -1 out and make that an I. Because remember, the square root of -1 is just I. So we make that out in front. And so now we continue to solve this by subtracting 2. So we'll write my solution as -2 plus or minus I times the square root of 7. And that's really all you can do. That's the only way you can write that solution. -2 plus I root 7 and -2 minus I root 7. It turns out the two solutions are both imaginary.